What's up, guys? Fantasia here. In this segment of Allegro game programming tutorial, we're going to be talking about animation. Okay, so getting our characters to move, with their motion. In the last tutorial, we talked about how to deal with characters as objects instead of an array of separate variables like their x's and y's and sprites. Because what we did was we created a new type called object using C++ classes, and we created our Mario and Sonic characters in terms of an object, a single object, instead of these separate variables. So now, instead of creating new variables every time we want to create a new character, we just make a new object and those variables come automatically with it. And that's nice because now we can not only handle 2 or 3 characters at a time, because we'll get tired of typing the same thing over and over. We'll be able to handle 50 enemies at a time if you wanted to. So in this tutorial we're gonna work on animation, so that's what I wanted to do. So let's get started. So last time we met, this is what our sample game looked like, and it's been this way for about 2 tutorials. The problem is that what we want to do is we want to have Sonic actually face the different direction, the other direction, because as you see, if I move to the left, he's still kind of looking out to the right. So we want to change that. And you say, oh man, well I already created a sprite that with my character looking one way. Do I have to make another sprite with him looking the other way? And the answer is fortunately no, because Allegro provides a function called drawSprite hflip and drawSprite vflip, which automatically flips your image for you in the other direction. So we're going to use that function in order to change our character's orientation. So let's do that. The first thing we want to do is try to figure out where it goes in our code, and we would quickly realize that it goes here, because when we move left we want to change his image, right? So that's what we're going to do. We're going to expand our if statement here. Okay, so what we're going to do is we're going to change some things in our object class. We're going to create a flag, okay, called Sprite hflip. Okay, I've already have it typed out here, and it's going to be a boolean, okay, or a bool, which essentially can only take on a true or a false value. Excuse me. So essentially our flag Sprite hflip is going to be true if we want to flip our image, and it's going to be false if we don't want to flip our image. And we put it in the public section of our object because we want to be able to directly manipulate it outside of our class. So in our definition, in our constructor, I've set it equal to false just so it can have an initial value. And down here what we're going to do in our draw is we're going to change Sprite, our draw function, to automatically flip it if the flag is true, and if it's false then it's going to draw it the normal way. So here's the function I was telling you about, is drawSprite hflip, and it essentially takes on the same arguments as drawSprite, except the only difference is it draws it with the axes flipped, so it draws it mirrored over the x-axis. So that's how that works. If we execute it, we need to add a few things though to our left and right movements. So what we're going to do is say if key left. So if we're moving to the left, what we're going to do is, oh wait, this is Mario's code. We want Sonic's code. That's down here. We want if we're moving to the left, we want to do this. We want to say Sonic Sprite HFlip equals true. Okay, so that's going to set our flag and tell our draw function to draw it with Sonic's image flipped to the facing the right. And if he's facing the right already and we go to the left, then we want to change it. So we're going to say Sonic Sprite HFlip equals false. So that'll reset it. So if he's facing the left already, we want to change the image back. So we'll set it equal to false. Okay, so if we run this, now if we move Sonic to the right, he obviously stays the same. But now if we move him to the left, Allegro takes that and flips it the other way. Okay, so that's nice, that's useful. So now he's actually facing the way that we're going. Okay, so that's pretty simple, pretty straightforward. But now let's say we wanted to actually add animation. Okay, so we know that Sonic likes to run. So what I did is I've got some sprites of him actually running. Okay, so that's the way I want this to look in our sample game. I don't know if the frame rate will actually let me run that fast. I don't know if that's going to show up well on the camera, but that's essentially what I want it to look like. Okay, so what we're going to do is we're going to somehow, we need to import those images into our code. So what we want to do is declare an array. Okay, and what's inside of this is going to be an array of strings or character arrays, which are strings. So these strings are paths, and they point to the files or the sprites in our computer, on the computer. So Sonic.bitmap, that's the one of him standing. That's this one. That's just that. That's the one with him standing. That's Sonic.bitmap on my computer. And now Sonic 2 through 5 is Sonic actually running. Those are his running frames. So I want to state the general idea here in a second of why we're doing this, just to get an idea. Okay, so basically the idea, what we're going to do, the general idea of animation is to get your frames of animation all together in a list or an array like I have here. And what you want to do is you want to iterate through those frames over and over again so that they're essentially repeating themselves and showing themselves all as essentially an animation. So remember, like a flipbook, the flipbook concept, that's essentially, these are the pages of the flipbook. You know, Sonic 2, 3, and 4, and 5, those are him running. And we want to show those, you know, in turn. And the factor that determines how fast they change is going to be accomplished through a clock. Okay, so since every character or object has a clock, what we're going to do is we're going to create and say that in our public we're going to create a frame clock. That's what I have here, and the frame clock is essentially a timer that ticks down every frame. Okay, and the frame, every time it goes to 0, it changes we're going to change our image to the next in line, the next in the list. So in our object implementation, I've set our frame clock equal to 60 to start out with. So what this means is that every time we tick down the clock, which is essentially a second, we every 60 seconds, or I'm sorry, since our frame rate is 60 beats per second, then if I set this to 60, it'll change every second. That's what the frame clock will do. I set it to 60, but we're going to change it in the program anyway. So that's what we've got there. So let me change Sonic's frame clock. Equal to 4. Okay, something like that. Actually, I'm going to start with 20. Okay, so the frame clock dictates how fast the images will run through the animation, and we're going to create another variable called Sonic Frame Counter. Yeah, I think I had it spelled right. And we're going to initialize it to 1. Okay, so the purpose of the counter is to point to the frame that needs to be displayed next. Okay, so for example, the frame counter is initialized to 1. That's because I wanted to point to the Sonic frame 1, this image here, because this is Sonic frame 0, and this 1, 2, 3, and 4, and so forth. That's how arrays work in C++. So we want it to count. We want the counter to start at 1, so we want to start here because that's Sonic's first running frame. And essentially what's going to happen is that we're going to increment the counter every time we show that image so that it points to the next image. So let's say we're on that animation. So this is Sonic. Okay, so this is Sonic 2. Okay, so every time we show that, then what we're going to do is we're going to show the next one, and then the next one, and then the next one, and then back to Sonic 2 again. So that's what the counter is for. It's just it's a counter. That's why it's called that, because it points to the image. So now what we want to do is change our actual movement code. So let me go here. So we want to create a variable called another boolean called Sonic not moving. And initialize it to true. And the purpose of this variable is to tell us indicate whether Sonic none of the arrow keys for Sonic have been pressed. So at the end of our Sonic movement code, if Sonic not moving still equals true, we know that no keys have been pressed for Sonic to move. This variable, although we won't be using it at this moment, it will be useful later. So we're going to set Sonic. We're going to set it equal to false here because if any of these keys are pressed, then we know that Sonic is moving. So Sonic not moving is false. We're actually going to leave down and up. We're going to leave those out of it. So well, I guess we could change it. Okay, and so we're going to put an if statement down here that says Sonic not moving equals true. Okay, so anything down here in this if statement only happened because Sonic isn't moving. So that's useful. That's a useful piece of code right here. So now that we have that variable out of the way, we need to create another variable. It's called a state variable. And the purpose of state variables is to describe the mode of being of a video game character. So like for instance, so in Super Mario Brothers, Mario has a lot of different states. Like he could be standing, okay, that's one state. He could be jumping, he could be running, he could be in the process of dying. That's all of those are different states. Okay, and states ensure that things only get executed one time and not every time the game loop runs. It describes what your character is doing, or his mode, like I said, his mode of being. So we're going to create a state variable, and it's going to belong to Sonic, so it's Sonic state variable. So actually a useful thing to do, since we know that every object in our game is going to have some kind of state or be in some sort of state, then we're going to add the state variable to our object class, and as I've already done here. And essentially the state is going to take on an integer value. So 1 is going to be a state, 0 will be a separate state, 2 is a state. And so that implies that a character cannot be in 2 different states at once. So for example, Mario can't be standing and running at the same time. He can't. That doesn't make any sense. So he's got to be in one state or another. So in our implementation, I've set the state equal to 0 just to initialize it. So and note that it's also in the public section along with Sprite, HFlip, and frame clock, so that we can change it outside of the program directly, outside of the class. So what we're going to do is we're going to change the state every time we move in a different direction, because we want to treat those as a different state. So moving to the right, that's a state, as well as moving to the left, that's a different state. So let's see, first off, let's change Sonic's frame clock like I said I would. Set it equal to Sonic frame clock. Okay, that just gives it an initial value of 20 instead of 60 that I specified earlier. And then here in this code, Sonic's movement code, we're going to treat this moving to the left, we're going to treat that as state number 1. Okay, so we're going to say if Sonic's state is not equal to 1, then set it to 1. So that basically says if state isn't 1, make it 1. Okay, and then we're going to put our HFlip inside of the brackets, because we only want to set the HFlip flag for his image only on the first run that the state isn't 1. Okay, so this sort of enforces that the flag only gets set one time. That's what we want. We don't want to keep setting the flag over and over and over. So that's why I put that inside the brackets. Next, what we want to do is move Sonic left. That gets done every frame. And then what we're going to do is tick down our clock. Sonic.frameClock --, which just decrements the clock. And then what's going to happen is that if the clock gets decremented and is less than or equal to 0, then that's when we want to change our animation image, right? So we say Sonic.frameClock. We want to reset it. That's what we want to do if the frame clock is less than or equal to 0. Is we want to reset the clock so that it's ready for the next countdown, so to speak. And then we're going to set the sprite equal to Sonic frames. So this basically sets Sonic sprite to the frame that comes next in the animation. Okay, and then what we want to do is increment the frame counter so that it gets ready for the next frame. Okay, and this if statement ensures that the frame counter doesn't go over the number of actual image that we have in our array. So this is 0, 1, 2, actually no, 0, 1, 2, 3, 4. Okay, so this is the fourth. This is element 4. Okay, so we don't want to go over because there's no more images in our array. So that sort of keeps our array in range, so it doesn't go out of range. So we want to go back to 1 if the frame counter is greater than 4. We're going to go back and go back to the first animation. Okay, so if that is all good, let's try to compile that, and it worked. So now if we try to make Sonic move, he doesn't move to the right, but now he's running to the left. Oh, now he's doing a moonwalk. so as you can see, Sonic he's now in animation, and that's what we want. Of course, it's not exactly correct, so we'll fix that. So what we want to do is fix the, let's see, false. Okay, so now we want to set it in the other direction, because it only works in one direction, so we want to change that. Okay, this code. Okay, so now we want to make it so it works when he goes to the right as well. So same idea. Sonic state, and when he's moving to the right, we're going to treat that as state number 2. State 2. So again, if his state is not equal to 2, set it to 2. And then, for the same reasons, we're going to do that. Frame clock. Set Sprite equal to Sonic frames, Sonic frame counter. Okay, and so now counter plus that will increment the frame that gets displayed next, and then Sonic's frame counter, if it's greater than 4 again, then we set it back to 1. Okay, and so now if we run it, so now he now runs in both directions now. So as you can see, it's like this. It's essentially just like the flipbook concept. So very cool. So now there's a problem, because if we stop pressing keys, he's still running, and that's not the way we want it. We want him to actually stand when we stop pressing keys. So okay, so we're gonna say if Sonic not moving equals true, then Sonic state does not equal 0, then set it equal to 0. Starting to see a pattern here. And then we're going to reset this sprite back to the first image of him standing, which is Sonic frames 0. That's the first one. Sonic.bitmap. And then say Sonic frame clock, set it equal to 0. That just resets the clock. Okay. And so now if we run this, if we run it now, let's get in focus here. Okay. So now he runs, and if I stop, he stands still. That's what we want. So this is great. Sonic is now an animation. The only problem with this is that you can see how slow his animation is running. We all know that Sonic is the blue blur. He should be running faster than that. So remember what I said dictated the speed of how fast the animations go? We're going to set that equal to 3, and I've tested it. It actually it's legitimate. That's just about how fast he goes. So now there we go. So now we have an animated Sonic. That is cool. And I mean, again, you could do the same thing for Mario. I have some frames for him, but I'm not gonna do them in this part of the tutorial. But that's how you would essentially do that. And like I said, you know, I'm only just showing you the general idea of how, you know, things are done in these games, and the specifics are really left up to you. You know, it's your game. You do it how you want it, and I'm just showing you how it usually gets done, and the main idea. So, you know, if you wanted to put all of this code, you know, all this frame code inside the object class, so all you have to do is call move left, and he automatically runs, you know, in frames. Then you go, you know, that's your choice. You go right ahead, and you know that I'm just showing you the general idea, you know, of how it would usually get done, and you know the specifics is just left. It's up to you. You're the programmer. So I mean, and now we have an animated Sonic, and it's great, you know. So in the next tutorial, we're gonna talk about some backgrounds, maybe, or physics, and both of those are important. Backgrounds give you something to look at, and the physics they control, well, the physics of the world, you know, collision detection is a big one, and so yeah, so it's cool. So I'll see you guys later. See you in the next video.